Welcome to tonight's video on linear inequalities and absolute value inequalities. Something probably different for you this year is when we do inequalities, we're going to use what's called interval notation. What that means is normally you would see something like this, where it's 1 is less than x, which is less than 5, which means basically x is between 1 and 5. Now to write that as an interval, we basically start with the smallest number, which is 1, and then we use the largest number, which is 5. And an open interval is one that doesn't include the two numbers. Notice how there's no equal to, so that's an open interval. And an open interval, you have parentheses. So basically a parenthesis means not equal to that number. Whereas a bracket means it equals that number. So if I changed and said 1 is less than or equal to x, which is less than or equal to 5, to write that as an interval, I would have a bracket for the 1 and a bracket for the 5. So that's the difference. Parenthesis, it's not equal to. Bracket, it's equal to. An infinite interval is something like x is less than 5 or less than or equal to 5, where it goes on in one direction because it's all the numbers less than or equal to 5. So when you look at that on a number line, here's 5, like let's say 0 is over here. If you go out to the left, that's said to be negative infinity, and if you go all the way to the right, that's positive infinity. Well, if it's less than or equal to 5, if you graphed it, it would look something like this, where you have a dot because it's less than or equal to, and it goes to the left. Well, to write that as an infinite interval in interval notation, remember you start with the smallest thing. Well, the smallest thing in this case would be the negative infinity, because that is the smallest term. And it's a parenthesis because basically it can never equal infinity, because infinity is not a number, it's a term. And then the next biggest term is 5. And since it's a dot there, and it's less than or equal to, you're going to put a bracket. That is an infinite interval. So another example, just to give you some more, is let's say you had greater than or equal to 2. So if you drew that on a number line, here's 0, 1, 2. Remember, you'd put a dot because it's equal to, and normally it would go to the right like that. Well, to write it as an interval, 2 is the smallest term, and then remember, infinity is to the right, negative infinity to the left. So since it goes to the right, the biggest term would be positive infinity. Remember, infinity is always a parenthesis because it is not a number, it is a term. And then 2 would be the first one, and since it's equal to 2, you have a bracket. If it just said x is greater than 2, notice there's no equal to, then that's when you would put a parenthesis, because parenthesis means that it's not equal to. Now it is possible to have something like this, where it says 2 is, the number x is between 2 and 5. But notice only one of them has an equal to sign. So you'd put a bracket around the 2, but a parenthesis around the 5, because brackets only go when it's equal to. All right, so now we're going to solve some inequalities. So for the first one, we move the 2 over. And remember, inequalities we solve just like equation. So we have negative 3x is less than or equal to 3. Divide by negative 3. and we get x, and this would be -1. Now remember, if you divide by a negative, and it should be divide or multiply, by a negative number, you switch the inequality. So since we're dividing by a -3, we're going to switch the inequality, so instead of less than or equal to, it's greater than or equal to -1. Now if I want to graph that on a number line, it looks like this, where you'd have 0, -1. You'd have a dot since it's greater than or equal to, and since it's greater than or equal to, it goes to the right. Now to write this as an interval, which you're going to have to do, since the smallest number is -1 and it's greater than or equal to, you put a bracket. And since it goes on forever towards infinity, infinity is next, and infinity, remember, always has a parenthesis because it's a term. Go ahead and try the next one on your own, and then I'll go through it in 10 seconds. You can pause it. So for this next one, you move the 1 over, so you have 3x is greater than 7x minus 16. Subtract the 4x, or what am I talking about? Subtract the 7x, and you get -4x is greater than -16. You divide by -4, so you get x is greater than 4. Actually, sorry, x is less than 4, because remember, you got to flip the inequality when you divide by a negative. So when you graph on the number line, if 0 is here, you'd have 1, 2, 3, 4. You're going to have an open circle because it's not equal to, and since it's less than, you're going to go to the left, which is towards -infinity. As an interval, -infinity would come first, and remember it's a parenthesis because it's a term, and then 4 would come next, and it's a parenthesis because it's not equal to. Whenever there are fractions, just like we've done in the past, we need to multiply by the lowest common denominator. Well, in this case, the common denominator is 6, so we take each term and we multiply by 6. So here you have 3 times x minus 4, because 2 goes into 6 3 times. 3 goes into 6 twice. And 6 goes into 6 once, so you have the 5 left. So when you distribute, it's 3x minus 12, 2x minus 4 plus 5. And then when you subtract 2x, you get x. When you add 12, you get greater than or equal to 13, which means on a number line, if 0 is here, 13 is going to be way over there. It's going to be greater than or equal to, so we move to the right. As an interval, you'd have a bracket on the 13 because the 13 is the smallest number, and since it's equal to, that's why there's a bracket. And since it goes to the right, it's going towards positive infinity. Compound inequalities are ones that have 2 or more inequalities in them. Well, for the ones here where the x is in the middle, basically what you do to one side, you're going to do to the other. So in this case, we want to isolate the x in the middle. So we subtract 3 from both sides. And then we divide by 2. So we get -1 less than or equal to x, which is less than 4. Remember, it means that basically the answer is between -1 and 4. Now notice I put a bracket here because it's equal to, and parentheses because it's not equal to 4. On a number line, if 0 is here, -1, you would put a circle with a filled-in circle there at -1, an open circle at 4, and you just connect. Go ahead and try the next one on your own, and then we'll go over it. Pause it. You subtract 1. Then divide by 2. So you get -2 is less than x, which is less than 1. And basically, as an interval, it's less than or equal to 1. So as an interval, it would be from -2 to 1, and 1 would have a bracket around it because it's equal to. When you graph it, here's -2, -1, 0, 1. So you'd have an open circle and a closed circle, and you just connect there. Last but not least, absolute value inequalities. Absolute value inequalities, remember, you always want to isolate the absolute value. Now, there's a couple things to look for here. If the inequality is less than, that means basically you're going to have two inequalities. You're going to have x minus 2 is less than 5. Or when you make it negative, you also flip the inequality. So it's going to be greater than -5. So just like absolute value equations, where you have two equations, absolute value inequalities, you also have two inequalities. Except when you make this answer a negative right here, you also have to flip the inequality. Now, we solve both of them. So we add 2 and we get x is less than 7. Or, if we add 2 here, we get x is greater than -3. So if you notice, if you graph them on the number line, here's -3 and here's 7. So it's greater than -3, so it goes that way, but it's less than 7, so it goes this way. So it's basically between the two numbers. So anytime an absolute value is less than like this, we could have set up a compound inequality, meaning we could have written it like that and solved it and got the same answer. So anytime there's less than, we can make it a compound inequality. So here's one. Let's isolate the absolute value. This is more complex. So let's subtract 20. And then we have -39. And then we divide by -3. So the absolute value of 5x minus 2 is less than or equal to 13. Actually, sorry, less than or equal to, and I wrote greater than, less than or equal to 13. So now we have an absolute value inequality with less than. So we can write a compound one. So we put -13 less than or equal to 5x minus 2 less than or equal to 13. So then we add 2 to both sides. We get -11 less than or equal to 5x less than or equal to 15. Divide by 5. So we get -11/5 is less than or equal to x, which is less than or equal to 3. And therefore, when we do our absolute value, it's going to be a closed circle here, a closed circle there, and it's going to be between the two. When we write it as an interval, -11/5 comes first, and 3 comes second, and they're both brackets because it's equal to. Now, my suggestion is you always want the x on the left-hand side. If it's not, then you can make it on the left-hand side by switching the inequality. So if I want to rewrite it like 6 minus 3x, the absolute value, it makes it greater than 18. So if it's greater than here with the inequality, we cannot make it a compound. But what we can do is we set up two inequalities. 6 minus 3x is greater than 18. 6 minus 3x is less than 18, negative 18. And then we solve. So when you subtract, you get negative 3x is greater than 12. Divide by negative 3 means x is less than, because you flip the sign, negative 4. When you subtract the 6 here, you get negative 3x is less than negative 24. Divide the negative 3, and you get x is greater than 8. So notice on this one, here's negative 4 and here's 8. So notice it's an open circle and it's less than, so it goes that way. And it's an open circle and it's greater than, so it goes that way. So notice this one, there's a big gap in the middle. And that's because originally the absolute value was greater than, so that's why we couldn't do a compound and put the answer between. So when we write this as an interval, we actually have two intervals. We have all the answers that are less than negative 4, which go from negative infinity to negative 4. And we have all the answers that are greater than 8. So 8 is the less one, and it goes to positive infinity. And we put a u in front, in between, sorry, to say that it could be in either set. This u means union of two sets. Basically, our answer is in either or. It's the union of those. All right, hope you enjoyed this video, and I will answer any questions you have in class, and I will talk to you guys tomorrow. Have a nice day.